Alright, this problem, stoichiometry problem, is called a mass-to-mass problem, and the reason it's called mass-to-mass is because we're given grams of a value of an item, and we're asked to solve 4 grams of something else. So when I read through, I see how many grams of ethanol, C2H5OH, which right here, are produced from 5.25 grams of glucose. The glucose is the C6H12O6. Just a little decomposition reaction from glucose down into ethanol. And there's also another product, carbon dioxide. This is a problem that is the longest type of basic stoichiometry because it requires the most amount of conversions. So let's start out with our basic setup. I'm starting way over here to the left because I know I'm going to need a lot of conversions to do this. Alright, what am I trying to find? Well, I'm trying to find grams of ethanol, C2H5OH. And what am I given? Well, I'm given 5.25 grams of glucose, C6H12O6. So I'm going to set up my bracket for my first conversion. And it would be nice if I could just go directly from grams of glucose to grams of ethanol. But I'm not going to be able to do that because we cannot convert from grams of one thing to grams of another because they're not the same size. They're not equivalent. What is the only thing we can use to convert from one substance to another in stoichiometry? Well, we can use the mole ratios. And even though there's not a 1 here, I can write a 1. It's an understood 1. And basically what that means is that for every 1 mole of glucose that goes through decomposition, I'm going to produce 2 moles of ethanol, the product. In other words, it's a 1-to-2 ratio. Where am I getting those? There's my 1, and there's my 2. I do have another product here, but I'm not concerned about it because this doesn't mention anything about the CO2. It is produced, but I'm asked to find ethanol, so I'm going to have to focus on the ethanol and leave the CO2 for some other problem. But I cannot go directly to grams. However, I can go from moles of glucose to moles of ethanol using my mole ratio. Well, this isn't in moles. Can I get something that's in grams and convert it to moles? Well, sure you can. Grams of glucose on the bottom to moles of glucose on the top. Now, whenever you're doing a mole to gram conversion, we always use a 1 here because that's the easiest number to work with. If I put a 2 here, I'm going to have to double my molar mass and so on and so forth. So I'm going to use a 1 here, and I need to know how many grams of glucose are in 1 mole of glucose. Well, of course, I need the periodic table for that because I got to figure out the molar mass. Well, I have 6 carbons. Each carbon is 12.01 grams. I have 12 hydrogens. Each one of those is 1.01 grams. And I have 6 oxygens, and each one of those is 16.00 grams. So I'm going to take all those values, I'm going to add them together, and when I do that, taking a few shortcuts here, I get 180.18 grams per mole. So for every 1 mole of glucose, I have 180.18 grams of glucose. So I'm going to put 180.18 right there. Now, I look at my conversion here. I'm left with a mole of glucose. I want grams of methanol, so I'm not even close yet, which means I have to make another bracket. What's going to go on the bottom? Oh, forgot to cancel my grams of glucose. So let's do that real quick here. Grams of glucose is gone. Now, I'm trying to find, again, grams of ethanol. But I can't get to grams of ethanol from moles of glucose. Not equivalent. Can I get from moles of glucose to moles of ethanol? C2H5OH. There we go. Is there a ratio from the balanced equation that I can use? Well, it's right here. Okay. For every 1 mole of glucose, I end up with 2 moles of ethanol. So what numbers am I going to put here and here? Well, what do you see next to glucose up here in the equation? I see a 1, so I'm going to put 1 next to glucose. What do you see next to ethanol in the equation? I see a 2, so I'm going to put 2 right there. My moles of glucose cancel. Now what am I left with? Moles of ethanol. Is that what I want to find? No, I want to find grams of ethanol. Well, if I've already gotten to moles of ethanol, I really only need one more conversion to get to grams. So I'm going to need another bracket. What's going to go on the bottom? Moles of ethanol, because that's what I'm trying to convert and trying to cancel out here. What's going to go on the top? Well, can I go from moles to grams of the same thing? Sure I can. So grams of C2H5OH. Fortunately, this is the last bracket. I'm not going to run out of space. Almost, but not quite. And what did we use over here when we did our conversion with glucose from grams to moles? Well, we used a 1. Now you notice there's a 2 up here for the ethanol. But I'm not going to put a 2 here, because again, if I put a 2 here, then I'm going to have to double the molar mass. I'm going to put a 1 here, because that's the easiest number to work with. How am I going to find the molar mass of ethanol? Well, again, I need to go to the periodic table. So I have 2 carbons. Each one is 12.01 grams. I have 6 hydrogens. Each one of those is 1.01 grams. Again, the 6, 5 there, 1 there, so 5 plus 1 gives you the 6. And there's 1 oxygen, and it's 16. Now, again, using the shortcut here, I'm just going to add all these values up once they're multiplied, and we get 46.08 grams per mole. So 1 mole of ethanol is 46.08 See if we can fix that. Well, technical difficulties here. 46.08 grams. Hopefully you can read that. And what happens to my moles of ethanol? They cancel. And what am I left with? I'm left with grams of ethanol. What am I trying to find? Grams of ethanol. So do I need any more brackets? No. I'm done making brackets, fortunately, because I've run out of space. Now what do I need to do? Well, it just becomes a big multiplication and division problem. I have 5.25 times 2 times 46.08. Then I'm going to divide that by 180.18. These ones here, don't worry about. Just the 180.18 is my denominator. And I'm going to round to 3 sig figs. And when I do that, I get 2.69 grams of ethanol, C2H5OH. And there's my answer. 2.69 grams of ethanol. So that means that if I have 5.25 grams of glucose and it decomposes and it's 5.25 grams, I'm going to get 2.69 grams of ethanol for my yield, my theoretical yield. And that's the longest type of stoichiometry problem, basic stoichiometry problem, that you're going to run into.